The recording. Welcome everybody. This is the first and only class on matrices. Yesterday we did curve sketching, or the last class was curve sketching. This topic is totally unrelated, and so if you're still having trouble with curve sketching, you can do this topic today. You can go back and try curve sketching again later. And then hopefully by the end of this class, I'll have some review that will prepare you for the types of questions you'll get on the final, which will be related to Unit 6 and 7. And then tomorrow's class, or the next class, which is Wednesday for us, I'll try to do review of whatever you feel like you need help with. Before I start, I want to make a note, which I said just before I turned on this recording. Expect on Saturday you'll have to use the Respondus lockdown browser, which should not be new to you. There are other courses which are already using them. Engineering has already mandated that students have to use it. And so you should expect to have to use that. And to repeat myself, it won't be in Zoom. As far as I know, it actually won't be in Zoom. It'll be in the lockdown browser, okay? So what I'm going to do is make a practice quiz, which is just a couple questions. I don't know, I might say like, what's your birthday? Or what's your favorite color? Whatever. Doesn't matter. It's just to make sure that your Respondus lockdown browser works. And if it doesn't work, then you got to get it fixed by Saturday, and I can help you do that, okay? But long story short, expect that you're going to have to use the browser, and what that means is that it just watches you. I know you're not comfortable with that necessarily, but it's only me that can see it. It just is a way of deterring cheating. And again, this is a college decision. It's not a me decision. It's a college thing. So if you have problems with it, talk to the president. Don't talk to me. If you have an issue, like if you have a question about it, of course, come to me. But if you want to say, no, sir, not fair, it's not fair, I would never cheat. It's okay. If you would never cheat, you don't have anything to worry about. Nothing's different. Okay? So without further ado, let's get started. So today we're going to work on matrices, which is a very complicated way of saying we're going to put numbers into boxes, which you might have seen these before. And these are called matrices, and we're going to do things like add them, multiply them, and solve systems of equations using them. So solving for X, Y, and Z. This particular matrix has what we call rows, and it has columns. In this case, we have 2 rows. Those are the horizontal ones. And we have 3 columns. And in this case, what you would call this is a 2 by 3 matrix. We call it 2 by 3 because that's how many rows you have compared to how many columns you have. You say you have a black screen. Ahmed, I'm not sure why. My screen is not black, so you might have to jump out and come back in because it might be on your side of things. There's nothing I can really do to help that right now. So this is rows and columns. This is just how we write the dimensions, also known as the size. The dimensions, also known as the size of the matrix. And again, it's just a way to collect numbers. It doesn't really matter right now what the numbers represent. All that matters is that we have numbers there. So let me see if I can fix the screen. Is this okay? Did this get fixed? Okay, yeah, there was an issue with when I was playing around the settings earlier. I must have turned something off. So just I'll repeat that really quickly. What I did is I said that matrices are numbers like this, put it in a box. The rows are well, you can see there's 2 rows. You can see here there's 3 columns in this particular matrix. And how we write this is 2 by 3, rows and columns. And that's what we call dimensions or size, okay? So you've all caught back up. Sorry about that. I was playing around with something earlier to close some things and I forgot to turn that back on. So hopefully you're back on track now. And again, we're just going to do things that we normally do with numbers and a couple new things that we can only do with matrices. But I think you'll find that the topic overall is very, very straightforward. The main points are going to be basic operations like plus and minus, multiplication, determinants, which are just a fancy thing we can do with matrices, multiplication again, inverses, and then we're going to solve equations. Okay, those are your big topics, and I think once again, once you get to the end of this, you're going to see, hey, much easier than curve sketching, very straightforward stuff. So let's get started. Definitions. A matrix is what we call a rectangular array, but really a matrix is just this. That's what a matrix looks like. What's the difference between a matrix and a determinant? Well, a matrix has square brackets like this. A determinant has vertical brackets like that. It looks like absolute value. It's not, but that's what it looks like. And every matrix, every number in a matrix is called an element. So just some terms. The dimensions, as we can see here, we have 3 columns and we have 4 rows. So what you would say is this is a 2 by 3 matrix, and the order matters. So 2 by 3, no, sorry, not 2 by 3. Why am I saying that? 4 by 3. 4 rows, 1, 2, 3, 4. 3 columns, 4 by 3. So it's right at 4 by 3 rows by columns. Okay, square matrices are just that. They have the same number of rows as they have columns. So 3 by 3 would be a square matrix, 4 by 4, 5 by 5, 2 by 2, and so on. It literally looks like a square. You know, a square has the same length and width. It can have any number of rows or columns. If it's filled with zeros, it's called a null matrix. All elements are 0. And sometimes you do the identity matrix where we have this column diagonal of 1s. But if we need that, we'll use it. Overall, I don't want to get you lost in the terms, okay? So what I will say is that the 0 matrix has the letter O. The identity matrix has the letter I. Those are just special names for the matrices. So if you see them come up later, that's what they are. Scalar multiplication is super easy. So look at this. It says, if this is our matrix A, we're calling it the capital letter A. Usually matrices have capital letters. Find 5A. It's just 5 times A. And the way we do this is really, really, really simple. We just, 5A is just going to be 5 times our matrix. And you just take every single element and multiply it by 5. It really couldn't be easier. So you take 3 times 5 is 15, 9 times 5 is 45, 4 times 5 is 20, negative 2 times 5 is negative 10. And that's how you do scalar multiplication. Pretty easy, right? You just, whatever number's in front, you multiply it by all the elements. It couldn't be easier as far as I'm concerned. So that's like a freebie for you. What I want to show you is on your Casio, and I know Nuran, you use the TI-84, and I think some other students do as well. But on the Casio, you can do matrices. You can also do it on the TI-84, which I'll show later. So on the Casio here, you'll notice I'm not in the right mode, so I'm just putting in the USB. On the Casio, what you need to do matrices, just let's clear this. You go to mode up here. You'll see matrix is number 6. So if you ever want to work with matrices, after you turn the calculator on, you press mode, you press 6. Now it's in the matrix mode. And we want to put in a matrix to our calculator. I'm going to say matrix A, which is number 1 here. Okay, 1. It asks me, what are my dimensions? Well, my dimensions here are 2 by 2. So I'm going to choose 2 by 2, which is number 5. And then it'll give me space to put in my numbers. And I'm going to put in my numbers. 3, enter, 9, enter, 4, enter, negative 2. And don't just put negative 2. You have to hit enter because you'll notice right now it has a 0. You need to make sure it has enter. You'll see the negative 2 in there. You'll see the negative 2 here. That means it saved it. Okay? And you want to get really good at this because you can do almost everything in this unit on a calculator if you want to. What you need to do now, you absolutely must do, is click AC. It saves it. So that's your save button, okay? Click AC. So you go AC. Now you'll see, look, it actually says matrix mode on top, MAT. And what you need to do now is remember, never touch mode 6 again. Okay? Don't touch it. What you want to do if we want to get to that matrix again is go into matrix, choose matrix in another way. So let me be clear what we're trying to do. I want to get 5A. So I'm going to put 5, and I need to multiply it by the matrix A. Well, we need to find where we saved it, which is actually under Shift 4. You see Shift here? You'll see matrix above the number 4. You hit Shift 4, and it'll say, hey, what do you want from me here in these matrices? Well, you want matrix A, because that's the one you just saved. So hit 3, and now it'll confirm that 5 times matrix A. Is that what you want? And if you've done it right and press enter, it now gives you 15, 45, 20, -10, which is exactly our answer. So you still need to do it by hand a lot of cases, but for some of these, or many of these actually, you can do it by the calculator. All right, and I'll review how to do that again later, but that's how we check matrices on the calculator. I've got a little summary of it that I'll post into the notes before I print them. Okay, so let's do these questions really quickly. This question 3A, well 3A is 3 times every one of the elements. So it's really easy, right? -3, 15, 0, -21. And you would do the same thing for the rest. So let's not. You get the idea. We don't need to do the practice. In this one, you divide everything by 4. In this one, you'd multiply everything by 9. It's easy. I don't need to show you another example on that. If it has a number in front, just multiply. Determinants are a little less easy. And it looks a little bit complicated. You'll notice it has these lines here. But all that means is we need to do a slightly different way. We need to multiply the diagonals. So look at this. It's kind of nice, actually. It's really visual. To get the determinant, which means these lines, multiply 4 by 3 and subtract -1 times 5. You see this? 4 times 3, subtract 5 times -1. That's your answer. Okay? Very, very, very simple. We can do another determinant if we want. I'll give you another example here. What if we want the determinant of 1, 2, -3, and 4? Well, you would just need to do 1 times 4, because we're doing the diagonal, minus these two multiplied. So I like to go top left, top right. So 2 times -3. That gives 4 plus 6, or 10. So our final answer is 10. That's our determinant, okay? Very simple once again. It's just a simple rule. Let me show you how to do it on your calculator as a reminder of how we set up matrices. So let's just say that I started, if you press this on button, or you press shift off, if you turn your calculator off, it clears everything. Okay, it turns everything off. So you need to start again. What we need to do is go to mode 6. Now we set up a matrix. We want to set up the matrix so we can get the determinant of it later. It's a 2 by 2 matrix, so I'm going to hit 5. Put in your numbers. Oh, it's saved there, but we're going to repeat with a new set of numbers. 1, 2, -3, and 4. So check your matrix. Make sure your numbers are okay. You can go around and look at them. This one looks okay. Hit AC. That is your save button. And now do the same thing we did before. Shift 4. And look here, number 7 is determinant, DET. So I want 7, I want the determinant. What do I want the determinant of? I want the determinant of matrix A, which I just made. So go back and find matrix A, which is number 3. Close your bracket. Now it says very clearly determinant of A. What we should get is 10, because I just found that. It's 10, okay? The reason I showed you that is that determinants of really big matrices are actually really complicated to get. You would need to put in, you know, maybe a 3 by 3 is much more complicated, but you can just put it in your calculator. All right. So Nuran, I think you have the TI-84. At the bottom of the notes, because I don't have time to, sorry, these 2 lines. Okay, let me be clear here, and then I'll say what I was going to say to Nuran. Ahmed, the 2 lines usually mean answer positive. For matrices, forget that. It does not mean it. It's a totally different thing. All right, just get it out of your head. For normal numbers, that's what it means. For matrices, it means we do this multiply thing. Okay, just totally different, totally different. What I was going to say, Nuran, is that at the end of these notes, if you scroll all the way down, it'll teach you how to use the matrices on your TI-84. If you can't get that, I will send you a personal message, or I'll make a video of how you can do it, okay? But most students aren't using that calculator, just a couple. so it's not personal. So find the determinant of each matrix. I'll just do one more of these. These you can put in your calculator and get the answer quickly. So the determinant of this, if I was to do it by hand, would be 9 times 1 minus 4 times -2. Which if you do that, that's the same thing as 9 plus 8. So that, in that case, is 17. That's our answer. And yes, it is positive, but that's just by chance. If I wanted to do the determinant of a big matrix, I would put it into my calculator. Okay? I would not ever ask you to do this one because it's a little bit too big. But this one I would do on a calculator. Can someone put it into your calculator now? I'll give you a minute or so to do it. And tell me what the answer is. Tell me what you get as the determinant, because then I'll know that at least one of you can do it. Because it's trickier than it seems. Mode 6, set up the stuff, never touch mode 6 again. I'll bring up what I think is my cheat sheet for this. Just give me a second. And by the way, at the very end of this is my cheat sheet. At the end of the notes, the Casio is page 16. The TI-84 is page 18. But my notes for the Casio, first step, hit mode 6. Second step, enter your matrix and then press AC to save it. Third step, do not hit mode 6 again. Then you go shift forward to your matrix stuff, okay? So someone tell me what the determinant is going to be of the question that I just gave. That's practice 1B. What's the answer? I'll do it on my own calculator while I'm waiting. This will show you how long it actually takes you to do this in case you need to do it later. Could be a nice question on a final. What I got, so we can check. -209. I want to know if anyone else got that. And as a reminder, your Casio stuff is given on page 16 in this book. Your TI-84 stuff is given on page 18 in case you have a TI-84. Is anyone doing this, or you just want me to put you out of your misery and move on? Normally, determinant, I would be able to like show a graph, or I'd be able to show something. Determinant is not something that is overly useful to talk about at this point, which is why I'm not going to talk about it too much now. So you have the black Casio, which means you can't do the determinant stuff. You can't do the matrices. I guess, I don't know, maybe you, how can you have Casio on the multiple choice? I'm not sure what you mean. Just to be clear, most of the questions you're going to need to do if it was a multiple choice later, like me, you need this calculator, this silver one, which they are the ones that are sold on at the bookstore. That's the one that has the matrices. If you don't have it, you'll just have to do it by hand. You won't be able to do 3 by 3, but you can do 2 by 2. And that would be all I would really ask anyways, okay? So let's just, I feel bad because if you don't have this colored one, you actually can't do the matrices. Yeah, 991ES, 991ES plus.
I mean on computer.
Hmm?
In computer. How can I have the Casio on computer like you?
So the one that I have is actually like not.
From where can I have this big?
I found this one online. I can send it to you.
Okay.
Or what Ahmed said in the chat, you can get it on mobile. There's a few different versions of the same one. I don't know the name, Ahmed. Could you just maybe tell us what the name is at some point? There's a lot of different ones. I have an Android, so it's different. On Android, on iPhone is different. but that's not something we should worry about this moment. For example, I have one called Calc Colorful, I think. It's a weird name, but this is on Android. But there's all sorts of names, yeah. Calc ES is the Casio style. You should be able to get that, and then you can follow the same steps as me, okay? In any case, most of what we're going to do today, actually, you're going to need to be able to do this on a calculator today, but the things I'll give you on the exam, let me think. On the exam, I think you don't actually need the calculator, okay? I'll tell you that now. You'll see later that you won't need it. But let's get to the point. The answer to this, if you had the calculator, is -209, okay? But really, you focus on how you would do it with a 2x2 for now. For C, I won't do. This one we can do without a calculator, okay? So let's do it. If this, the determinant of this is 12, notice that these lines mean that we are trying to get the determinant. We follow the same steps. Multiply, multiply, and subtract them. So the determinant of this is 7 times 4 minus 2t times t. That is 28 minus 2t squared. All right, and it's saying that 2t squared, that determinant equals 12. So in other words, this is kind of our first step. Our second step, it's saying that our determinant equals 12, so 28 minus 2t squared equals 12. Where did I get that 12? From the original question, okay? Now I just solve for t. That means -2t squared is 12 minus 28. 12 minus 28 is -16. You can divide both sides by -2. That means that t squared is 8, which means t, of course we need to do the square root. It'll cancel. What is the square root of 8? I think it's what, 2√2, maybe? I haven't had enough coffee today. I think it's 2√2, yeah. Okay. So the question, this is more like something that you would get on the exam. I call it an exam, it's just the 10 multiple choice, because you don't actually need the calculator to do this for you. You just do the basic determinant, which is multiply the diagonals and subtract them. And it says that the determinant is equal to 12, so this equals 12, which is what I did here. Solve for t. All good? Can I get a thumbs up? Yeah, I'll give you a thumbs up. I gotta turn on the AC, it's really warm in this room. I'll be right back. I think, would it be correct in saying that you're all basically burned out and tired and your brain is mush and you just want to be done with the term? I'm not saying that that's necessarily how I feel, but I have a lot of students telling me that they're basically just done. They got so much on their brains. So I understand that. That's why I'm not actually trying to pick on you too much. I'm just giving you the information and you can watch the video later if you don't get it now. All right, let's move on. If you need me to stop, please let me know. No one's talking in the chat today, so I'll just pretend that everything's cool. And if you need me, of course, let me know. What's going on? Basic properties of matrices. Basically, it says that they work like normal numbers. And the best way to show this is an example. For example, for these two matrices, it says find 3 times b. Well, we already did this rule. It's 3 times b. So take your B matrix and multiply every single element by 3. So that's pretty simple. I'll just do the first column. 9, 2 times 3 is 6, 4 times 3 is 12, -5 times 3 is 15, 27, -6, 24, 0, and 9. So you just take every element of the matrix and multiply it by 3. The next one would be the exact same. Actually, I'll do it because part C is asking me to do it. 2 times A. So multiply every element in A by 2. 6, 4, 2, 4, negative 10, 0, 14, 8, and 16. It says now take 2A minus 3B. Well, I have 2A and I have 3B, so I can take the answers and subtract them. So what you're going to do is you almost like put them on top of each other. It'll be 2A, and we're going to take away, you can imagine taking away all these, see how they like are related to each other right on top? That's the way that we're going to do this. So I'll write it out so it's clear. We're going to have all the elements of 2A minus 3B. So 6 minus 9 goes in that space. 4 minus negative 15 goes in this space. 14 minus 24 goes in this space. I'm going to move, actually this is enough space. So to be clear, 2A minus 3B, it's this element minus this one, goes here. 4 minus negative 15 would go here. 14 minus 24 would go here, because we're relating each element, each position to each other. We're just subtracting them. So 4 minus 6, negative 10 minus 27, 8 minus 0, 2 minus 12, 0 minus negative 6, and 16 minus 9. So hopefully that's clear to you. I just need to do all of those calculations and I'll get another 3 by 3 matrix. It'll be negative 3, negative 2, negative 10, 19, negative 37, 6, and what's 14 minus 24? Negative 10, 8, and 7. Okay, so you just, once again, take each element and subtract from the other. In other words, you can almost think of it as this is how they relate, right? I said this before. It's the elements that would lay on top of each other here. So imagine these are the numbers that relate to each other. I know that's messy, but that's how my brain thinks about it. Okay? And then it says, for the matrices A and B given above, use a calculator to evaluate the determinant of each. You don't seem to all have a calculator for that, but I'll let you do that for homework. It just means get the determinant of A and get the determinant of B. And the full solutions will be online if you want to check that, okay? Let's solve this for the value of t. This is more interesting. Let's see if you can figure this out. It says, what's the value of t in each of the following? So I need to figure out t, we need to figure out t. For the first one, remember all these elements are related. So 6 is of course equal to 6, 4 is equal to 4, 4 is equal to 4. That means that negative 10 is equal to 2t. And that's our most important one. So negative 10 equals 2t. What does that tell us? Well, we solve that for t. Yeah, Tadek already has this. That means, of course, if we divide both sides by 2, t equals negative 5. So matrices, students, especially if they haven't seen it before, they look a little bit intimidating because they're all these boxes and things, but they're not that bad, really. They're really not that bad. They just look complicated. On this side, we have two determinants. Determinants. So let's see how this works. This times this, minus this times this, equals this times this, minus this times this. So I'm going to do the left side first. I'll show you that I'm going down the middle here. I'll do the left side and the right side. So the left side, negative 2 times 1, minus 5 times 3. That's my left side. On my right side, 3 times 9, minus 4 times t. And now we just solve this for t. So this is negative 2 minus, I'll just solve the left side. Negative 2 minus 15, negative 17. This is 18 minus 4t. So again, solve for the 4t. Bring that over. That's negative 17 minus 18. I think it's negative 35. Let me just double check that. Negative 35 is correct. Negative 4t. Divide both sides by negative 4. And we get our t value. So whatever negative 35 divided by negative 4 is, which apparently is not able to be simplified, or we can say it's 8.75. Okay, how do we feel about that? I want to make sure that at least one of you is still alive out there. I do care about you all, you know, whether I've seen you lately or seen you ever. I do care about your safety and your health. I want to make sure you're still there. And I don't need to call the ambulance or something. All right, so let's move on. To me, it's simple. It's very simple rule. We've only learned one really, just the new cross rule. Let's do some matrix multiplication. Now, matrix multiplication, what it says is in order for you to multiply matrices, you need to have the same, what's called dimensions of the matrices. So let me just see the best way to do this. What it's trying to say here, I'll put as an example. If you want to multiply two matrices, they have to have the same number of rows, columns in the first one as the rows in the second one. So for example, if you had a matrix A and a matrix B, first one was 3 by 3 and the second one was 3 by 2, you need to just check, are these the same? And if they are, then you can multiply them. And in fact, the resulting matrix will be a 3 by 2 in the end. If you had another example, let's just say you had a 3 by 3 again, but then you had a 2 by 3, you check the insides, it's not okay. We're not allowed to multiply that. So really, sorry, my computer is freaking out again. Can't multiply. All right, this is the big idea. You check those dimensions. If they're the same, you can multiply. If they're not the same, you're not allowed to multiply. That's what it's trying to say here, okay? When it says not all matrices can be multiplied, the number of columns in the first matrix must equal number of rows in the second matrix. Okay, let's do this. How do you multiply them? Well, it tries to tell us based on this weird looking grid here, but let me help you get through it, okay? Let me color code this. It says that if you want to multiply them, you have to take the rows of the first one and multiply them with the columns of the second one. And you'll notice that you go step by step. So for example, you multiply A by E, and then you would multiply B by G and add them. So that together gives this, A times E plus B times G. And you go further and further down the rabbit hole with this. So I've got a little bit of a demonstration here. I don't want to make it too confusing for you, but just to try and talk about this, let me try to make this as clear as I can, which is always my intention. Notice we have the matrix A. If I want the answer, it turns out the answer here is this, but why? Well, what you do is you take the first row of the first matrix, multiply it by the first column of the second matrix. Each term will multiply together. Look, the 2 and the 4 give 2 times 4. And then the 3 and the 2 give 3 times 2, and you add those results. What do I get? I get 8 plus negative 6, which gives 2. And that goes back and goes into the first row, first column of the final matrix. And you go on down like this. So just let me show you what happens if I wanted first row, second column. Notice how this changes, okay? It now is taking the first row of the first matrix, the second row of the second matrix. It's going 2 times 1 gives 2. 3 times 1 gives 3, and you add those results. It gives you 5. It's almost like you take one and place it on the other. What I mean is, you know, you have this row here. It's almost like you imagine that, take it and like imagine multiplying by this. You know, you have 2 and 3 was there, you had your 1 and your 1. Take this and it comes over here. It's almost like you have 1 times 2 and 1 times 3. Or in the other case, where we had first row, first column, imagine it's 2, 2 and 4. It's almost like you have 2 and 3 there. And then the rows, the columns of the other come on over and go 4 times 2 and negative 2 times 3. And then you add those results. So like, let me show you what it looks like on paper here. Because for some students that'll be clear and for others it won't be. Find AB if A is this and B is this. So first of all, we need to make sure if we're even allowed to do this. So the first matrix has 3 rows and 2 columns. That's A. The second matrix has 2 rows and 4 columns. That's the B matrix. Can I multiply these? Am I allowed to multiply them? Will it work? Yes or no? It should be a very simple case of if I can or not. Al-Sadegh says, yes, I agree, because the 2 and the 2, they're equal. So we're allowed to multiply them. The final matrix actually will be a 3 by 4. The final matrix will be a 3 by 4. Let me show you how it works. I'll write down every step the first time. So A times B, I know it's going to be a 3 by 4 matrix, so I'll make it big. First things first, multiply 2 and 1. I want the first row and the first column. I want something in the top left here. Multiply these together. I get 2 times negative 1 plus 1 times 3. All right, first row and first column, first row, first column. The answer to that will be what's in that slot in the top left of the matrix. And I have to keep going through this. Let's try first row, second column. First row, second column is 2 times 6 plus 1 times 0, because I'm going 2 times 6 and 1 times 0. That's how this is working, okay? Once you see what's going on, hopefully it'll be clear. I'm going to go first row, third column. So it'll be 2 times 5 plus 1 times 1. And then the fourth, I'm going to go first row, fourth column. 2 times negative 2 plus 1 times negative 4. Okay, and I need to keep doing this. Now I could do it, you could do it kind of as you go. You don't need to show all the work, but we'll see later that it's better to show all the work, okay? So now I'm going to go second row, first column. What's my elements? Someone just tell me what this one's going to be so I can see that you're actually following. What's my answer going to be for the second row, first column in my new matrix? Anybody? You say 0, and I say you're correct, because it's negative 3 times negative 1 plus 0 times 3. Actually, it's not 0. It's going to be 3 in total. Nasser, you're saying negative 3 and 0. Well, it's negative 3 plus 0. So be careful here. Or, sorry, negative 3. It's negative 3 times negative 1, which is positive 3, plus 0, which is going to be positive 3. Let's keep on going. I'm going to do second row, second column. And again, I'm going to show every single step. I won't always do this. And this is 0 times 0. I could have ignored that. Second row, third column. So negative 3 times 5 plus 0 times 1. I'm going to do second row, fourth column. Negative 4 times negative 2 plus 0 times negative 4. And now I got to work down and say, what about my third row, first column of my last matrix? It's going to be 1 times negative 1 plus 2 times 3. And I'll keep going down. 1 times 6 plus 2 times 0. It'll be 1 times 5 plus 2 times 1. And finally, 1 times -2 plus 2 times -4. So this is a lot of work. This is a big matrix. And in fact, I won't even be able to write my final answer here, really. I'm going to write it out to the side, and I'll make it smaller, actually. But I didn't need to show all the work, or you don't need to show all the work when you do this. I just showed it so that it would be helpful for you, okay? So those are all my steps. Notice that if I was to really lightly draw in here, you can see that this is first row, second row, third row. I have all these different elements. You'll notice I have a 3 by 4 matrix. They're not all on one line. They're actually separate areas of the matrix. Just like these are all separate numbers, and these are all separate numbers. There are actually 6 different elements. So I'll write out my final answer here. It should be pretty quick. I'm just going to do some quick calculations. This is -2 plus 3, which is 1. 12 plus 0, so 12. 10 plus 1, 11. -4 minus 4, -8. 3 plus 0, that's our 3 we were talking about. This is -18. This is -15. This is 6. -1 plus 6 is 5. 6. 5 plus 2, 7. -2 minus 8 is -10. You with me so far? It looks scary, but honestly, the steps are very mathematical. They're very logical. In fact, computers are very good at this. Computers can just spit this out. In fact, it's the whole basis. It's linear algebra, which is the basis behind how like Google does web searches, but I won't even start into that kind of thing. It's beyond this course. Does the recipe make sense? Anybody, 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 anybody? I'm talking to the void. I see Tarek has an endless thumbs up, so I'll go with that. And it was probably from an hour ago, but all good. I want to give a smaller example because I feel like this is a bit much to give for just like a first example. So let's do another example. If you need me to go back to that, I will. Let's see. Let me make one up. What if we had this matrix? I'll say just 1, 2, 3, 4. We wanted to multiply it by 5 and 6. Okay. This is a 2 by 2. This is a 2 by 1. It's a 2 by 2. 2 and 2 are the same, so it's good. The answer will be 2 by 1. So I already know ahead of time my answer is going to be 2 by 1. Let's go ahead and write out the answer. What's it going to be? It's going to be a 2 by 1. So I can already make this space. How am I going to do it? It's going to be 1 times 2 and 5 and 6. Sorry, not 1 times 2. It'll be 1 times 5 plus 2 times 6. So 1 times 5 plus 2 times 6 on my calculator is 17. That is my first row, first column. Notice first row, first column gives me first row, first column in my answer. Let's just go one step further. And I need to do second row, first column, which is 3 times 5 plus 4 times 6. The answer is 39, which is indeed a 2 by 1. So I know that this is going okay. Once again, I don't know who's there and who's not. I'm going to keep on going as if I had a class filled with 1,000,000 appreciative students, because that's just how I go. I'm going to write this in the Casio so you can follow along. Mode 6, matrix 1. It's a 2 by 2, so 5. You put in 1, 2, 3, 4. If you have VTI-84, you can use this time to try it yourself. AC is save. Now I go shift. This is a new option. I said never touch mode 6 again. So you go shift matrix. How am I going to put in the second matrix? This step's very strange. You actually have to say dimensions. You have to dimension or set the dimensions of a new matrix, which is 1. You do not press number 4 because you haven't saved one yet. So you click 1, it'll say, okay, a new matrix, huh? What kind of matrix? Well, you want matrix B, or a second matrix. So you press 2. You know it's a 2 by 1, so that's the option 6. And now you set it up. 5, enter, 6, enter. Now they're saved in the background. I want to multiply them. So I go Shift 4. I want to call matrix A. I'm going to multiply it by Shift 4, call matrix B. So it says you want to do multiply matrix A by matrix B. Are you sure? And you say, yep. Press enter. I should get 17 and 39. And I have 17 and 39. So I know that my answer is correct. Right? So this is how we do those things on the calculator. Hopefully it's clear to you. I'm going to go ahead as if it is. And of course, as always, if you don't have, if you're not clear on exactly what I'm doing, you got to just let me know. And I'll make sure that everything's peachy keen, okay? But this is how we multiply matrices, no matter how big. So the process, I'm not going to do the next one. That'll be for you to try, unless you want me to, but you can let me know. What you do, if you want the first column, first row and first column of your new matrix, you multiply all these numbers together. It's almost like you take the column and put it over on top, right? So you would say 5 times 3, and you would do 6 times 7, and you go 2 times 7, and 7 times 0. That's how you figure out those answers. And then if you wanted, for example, the second row and the third column, or sorry, second row and the second column of your new matrix, you would add all those numbers, those products together, okay, and so on. Can I just have an idea of how you're doing? Can you say, do you want me to do this example, or would you like me to move on? Just say example, or move on. Example, example, okay. 2 people saying example is enough for me. I'll do another example. Again, I highlighted this earlier so you can follow my steps. So I'm going to keep doing that because when you look back on the video, you can compare. All right, so let's do this. I want to do A times B. First of all, I need to make sure that they're actually going to be possible. Ahmed, I can't actually do this with the calculator because the calculator doesn't have bigger matrices than 3 by 3. The matrices in the calculator, if you go into the mode, the biggest you can make is, I think, yeah, 3 by 3 is the maximum. So we don't have a choice. We can't use our calculator for this one. Not on the Casio. So we're going to have to do it by hand. Here, I'm going to just write these in. I'm going to show less of the work this time. I know this is going to be, this is a 2 by 4. This one's a 4 by 2. And so the inside numbers are the same. We're going to have an answer, which is actually a 2 by 2. So the answer is going to be really small. I'm just going to have something in these spaces here. The pencil there, that is not actually how you write this. I'm just giving you an idea that we're going to have 4 elements. So let's do the first element. You'll notice that it's the first row, first column. Or in other words, it's where these crossed. First row, first column. I'm going to get an element here, okay? Let's do it. It's 3 times 5. I'm going to do it in my calculator, just literally. I'll show you how I do this without the matrix mode, just regular calculator. So mode, I need to go back to calculation mode. So mode 1. And this is how I do this. For the first row, first column, I go 3 times 5. So the first element's multiplied, plus the second element's multiplied, 7 times 6, plus 1 times 2, plus 0 times 7. Hopefully you should notice it's the first elements, second, third, and fourth all multiplied together. So 59 is my answer. That's what goes in here, okay? And this is why. My 4 elements all multiplied together. what do I do next? The next row or the next column? Well, it doesn't matter. So I'm just going to do the second row, first column, just for fun. Okay. I'm going to do these. I'll do it in my calculator again. The first elements are 0 and 5. And I'm going to add 1 times 6. Those are my second elements. Plus my 9 times 2. Plus my 4 times 7. The answer is going to be 52. So you can see it's going to be 52. How do I know it's that one? Because look, second row, first column, second row, first column, it's where they intersect. Okay, it's going to be right here. Hopefully you can see the logic now. I'll do my first row, second column. Let's see what we get. You should be able to beat me to it, okay? I want to see an answer in the chat for this one. 3 times 2 plus 7 times 3, so 21. Plus 1 times 1, so plus 1. Plus 0 times negative 9, which is going to be 0, but I'm going to write it here anyway so you can see it. What do I get? I get, is anyone going to beat me to it? Oh, no. 28. And finally, I need my second row. I want second row, second column, second row, second column. I need to take the second row of my first one and multiply it by the second column of my second matrix. And then I'll have what I need. Ooh, negative 24. So you beat me to it. Let's see. 0 times 2, so 0. 1 times 3, 3. 9 times 1, so 3 plus 9, 12. 4 and negative 9 is negative 36. Negative 36 plus 12, negative 24. So you got it. And once again, I knew what the size was going to be because I figured that out beforehand, right? This and this gave this, the remaining ones after I did my little check, okay? And once again, these boxes here, I'm not going to keep them because they're not actually part of the matrix. They were just there to show you where the elements were going to go. So I've erased it. This is my final answer. And this is how we do matrix multiplication. Okay. Hopefully that's more clear now that we've done the example. I'm going to put it over here so there's a bit more space. And that's how we do it. It doesn't even matter. We could put variables in this and it would still be fine. It wouldn't change anything. It would just be done this way. The only little trick it says at the very end of the page here is that matrix multiplication, the order matters. So this is what it's saying. It's saying order matters. Or order, like A times B is different than B times A. So A times B is not equal to B times A. So if you actually took B first, wrote B first, and put A second, you would get a totally different answer. In fact, it would be a 4 times 2 matrix times a 2 by 4. So it'd still work, but you'd get a 4 by 4 in the end, which is not the same, of course, as our answer here. So just giving you a few things to think about, but most of these ideas are pretty straightforward. Okay. Before I move on, can I just get an idea of how that is? Is that okay? That's probably the hardest topic in this unit. In fact, I know for a fact it's the hardest topic in this unit. Is it okay? It's actually why we save the matrices for last, because they're totally unrelated to anything else in the course. And they're quite easy. So even if we don't have a lot of time to teach it, students still do well on it because the steps are clear and logical. And if you have issues with it, of course, just watch the video again or send me a direct email or a message. I always have no problem writing something new out for you if you have specific questions. It's just the way I am. Okay. Let's get this content done, and then by the end of the class, I'll review some of this. It's talking about the identity matrix. The identity matrix is a matrix that has ones on the diagonals and zeros for the rest of the elements. What it's trying to say, and none of you did IT math as far as I know, but if you did, it's just saying that if you have a matrix A times I, or I times A, it gives you back the original. What it's saying, it's actually saying it acts like a 1. The identity matrix for matrices is like a 1 for regular numbers. Just like if you had the number 5 and multiplied it by 1, it's the same as 1 times 5. It just gives 5 back. That's all, okay? So what it's saying here, it's saying find AI and IA. Okay, well, I, for a 2 by 2 matrix, looks like this. 1's on the diagonals. And 0's everywhere else. So it says it wants AI, A times I. So that means take the matrix A and multiply it by the matrix I. So what we're going to get is a 2 by 2 matrix. Once again, I'm just going to multiply all my elements together in the same way I did before. I'll start with the first row, first column. So 7 times 1 plus 1 times 0, that's a 7. 7 times 0 plus 1 times 1. The next one, 3 times 1 plus 2 times 0. The next one, 3 times 0 plus 2 times 1. Just following the same rules that I followed before. What you'll see is we get back 7, 1, 3, and 2, which is the exact same thing I started with. Right? A is what I started with, which is what I ended up with. It's just saying that if you multiply any matrix by I, you're going to get the same matrix back. It's just a fancy thing that we get with matrices. It's the exact same thing as multiplying by 1 with numbers. It's just in matrices, we have a lot of numbers in this like row and column form. In order to get back the same matrix, you have to give an identity matrix instead of just multiplying by 1. It's kind of a special case. I'm not going to get into it any more than this. I just wanted to show you that it exists, just in case it comes up in a later course. Inverse of a matrix. So it says, we know how to multiply matrices, so you may wonder, how do we divide matrices? You know, we already multiplied matrices and saying, how do we divide them? And the answer is we don't, and we can't. We can only multiply, but that's okay. Let me show you how. Let me try to find a good point here. Right. It says, just look at this real close, literally really close. This is the idea behind inverse matrices. What you would do, let me just set this up to the side. Let's just say it says we want to solve for matrix B. Okay, and normally, let's just say we had AB equals C. In a regular situation, in order to solve for B, you would want to divide by A, right? You divide both sides by A, that would cancel this, and you'd end up with B is, 1 over A times C is really what we have, or C over A. But with matrices, we're actually not allowed to do that. We're only allowed to use what's called the inverse. It works a lot like sine functions. So let me rewrite this so that you can see what's going on. AB equals C. We're not allowed to divide by A, but we can do one thing better. We can apply A inverse to both sides. So the inverse of A times A, that will actually cancel and disappear. But we have to do the same thing to both sides. All right, that's the same as dividing. So our answer is actually B is whatever this mysterious inverse of A is times C. And so in order to get these answers, we just need to get what's called the inverse of the matrix, which is actually only a really quick 2 or 3 step process. Okay, so think of it like dividing. I'll just put it again to the side. If I want you know, AB equals C, and I'm looking for B. You want B alone. You do the inverse. So you can essentially cancel it from that side and add it to the right, right? That it's like dividing by it. It's like getting 1 over A, except we have A inverse, okay? So that'll come up again later. Let me show you how this works. I don't know why it's giving this. I'm just going to skip that example just because I'm dangerous like that. The inverse of a 2 by 2. It's a 3-step process. It's always the same 3 steps. Interchange the elements on the principal diagonal. That means switch them. Switch them back and forth, okay? Swap them. Change the sign of the elements that are off diagonal, and then divide each resulting element by the determinant of the original matrix. Let me show you how this works, okay? Let's do what it says. It means A inverse is, it says interchange the elements on the principal diagonal. So on the diagonal, we have 2 and 7. It means change their order. -7 and 2. All right, I've swapped them. My first step is done. Second step, change the sign of the elements that are off diagonal. These elements, I change the sign. -3 turns into 3, 4 turns into -4. Okay? And the third step, so I've done the second step. The third step, divide each resulting element by the determinant of the original matrix. So the determinant of the original, what is the determinant? Well, we need that. The determinant of A. Does anyone remember how to do it? The multiply thing? It's 2 times -7 minus -3 times 4. So 2 times -7 minus -3 times 4. That's the determinant of the original. That's what we did earlier. That's what? 2 times -7 minus -3 times 4 gives us -2. So let me make this a little more clear. This should have said A, really. So really what I'm doing, I have -2. I'm going to divide every term in my matrix by -2. And this will give us our inverse. So our final answer is, what's -7 divided by -2? It's 7 over 2. What's 3 divided by -2? It's -3 over 2. What's -4 divided by -2? It's 2. And what's 2 divided by -2? It's -1. That's a heck of a lot of work for something that's just flipping some things around. So the easiest way to do this is to use your calculator. So most students are like, yes, calculator. If you don't have the calculator, then we have a problem. But I'd recommend maybe before Saturday, just go buy it. It's not very expensive. You can have it for life. It'll do you good for any math course. Let me show you how I would do this on the calculator so that you can see it's actually better and faster to do it on the calculator. So we'll go mode 6. I'm going to set up a matrix, matrix A. It's a 2 by 2, so I'm going to hit 5. And I'm going to put in my numbers of the original matrix. 2, -3. Again, this is the original matrix A. 4, and -7. So now I have my matrix A. In order to save it, press AC. Now never touch mode 6 again. Go to shift 4. And call your matrix. You want to get the inverse of it. Remember on this page here it says A with the -1. For matrices, that means inverse. So you need to set this up. Your calculator wants to see it in the same way as your math textbook. So you call the matrix first, matrix A. By call, I mean get it out of the memory of the calculator. And then what are we going to do? We need to find that -1 symbol. Do not use the exponent. Don't use this. Use this. This is your inverse button, okay, in the top right. Now we see it says matrix A, get the inverse. As soon as I press enter, I should get if I've done this correctly, I should get my final answer. All right, 3.5, and it says 7 over 2. Next one, negative 1.5 or negative 3 over 2, matching what I see here. Next answer, 2. 2. The next answer, negative 1. All right, pretty nice. And this is a rare case where if I ask this question, go ahead and use your calculator, okay? Anytime you ever need to do a matrix later, you can do the calculator to find the inverse. I don't need to see every single step, okay? How do we feel about this so far before I show you maybe another example or two? You're all quiet today. Okay, it's clear. Thanks, Alsadeg and Aisha. You're keeping me going here. It's not easy to do this. Be in a room alone and just talk to people out in space. So it's nice to see that you're still there. What about the last answer with the calico -1? Excuse me? With the calculator? What about the last answer with the calculator? I just spent the last 5 minutes going through the answer with the calculator. Did you fall asleep? You mean, sorry, 1 second. There's -1. So, okay, are you talking about this -1? Or are you talking about this -1?
No, mister, in the calculator. If you open
Okay,
the yes, this
what
one. On the right. Down.
Let me try and figure out. Here?
Yes.
Oh, that's just saying whatever I'm highlighting at that time is the number that'll come up there. So when I move around, oh shit, I just crashed it. If I press the arrow keys, right, these middle ones, that number will just pop up in the bottom right. It's just a way of seeing it more clearly.
Oh, okay.
So I think that, yeah, so I have the surface. I'm assuming that's what you know I'm using this whole time. If I bring up this calculator on the surface and I touch, this is a touch screen, if I touch it, it crashes.
Okay.
That's so slow for me. Anyway, don't worry about that little negative in the negative in the bottom. It's just giving you the current selection.
Okay.
So let's keep on going. We're almost done. Honestly, we only have one more topic, and then you're done the entire course. It should feel pretty good. Let's try to get the inverse. It says use the graphing calculator or any calculator to find the inverse of the following matrices. So I'm going to do one more just as an example. I'll do the first one. They're all the same. And then I'll move on to the very last topic, which is solving equations. Really easy topic, honestly. But you do need the calculator for that. And then if we have time, I'll start giving you hints on what to expect for the final. Okay? So this is calculator work, and so I'll go right from the top once again. Those of you who have a calculator and you want to practice this, this is your chance to do that. So once again, once you're in matrix mode, if you get stuck there, remember hit mode and then 1. That's your comp mode or your computation mode, your regular math mode. But I want matrix mode. 6. I want to set up matrix. It says matrix C. It could be anything. It could be X or Z or P. It doesn't matter. It's just a letter. So I'm just going to say matrix A because it's just whatever. It's the first one I'm saving in my calculator. It's a 3 by 3. So number 1, follow your regular steps. Okay, your recipe. -1. Great. This is much faster if you're not using a touchpad. -6. Make sure you don't make a single mistake here. Be very careful because if you put in 1 digit wrong, every single answer after that point will be wrong. -10. -4. 34. And -5. So I'm just going to check over it to make sure that everything's okay. And you'll notice now, Ahmed, the number in the bottom right is just my selection. You see that now? See that? Okay, so -1, 8, -2, -6, 49, -10, -4, 34, -5. So my matrix is fine. A lot of students at this point hit on, like they'll hit on or they'll go shift off. If you click anything but AC, you'll clear your whole memory, okay? So you need to always hit AC. That's the only way to save that in your calculator right now. And what I want to do with it now is get the inverse. So I need to go to Shift 4 to call up my matrices. Call back matrix A. If you called it matrix B, call matrix B. If you called matrix C, call matrix C. And remember, this is the only button you can use for inverses. You cannot do a power of -1. You can't do anything else. You have to click this for inverse. It's the X -1 button. And once you do that, this is the inverse. Now the answer is not 95. The answer is, it's gonna fight me, is it? I'll find a way around this. And sorry, my touchscreen is fighting me today, which is nothing new. I'll write out the inverse. You need to know what the notation is. It's C with a little inverse. It looks like the -1 that we have on our x's, yeah? It's the same idea. C to the -1, which means inverse of our matrix, is 95, 10, -8, -28, -3, and 2, 18, 2, and -1. And we're good. That's all we need to do for inverses. So I want to be very clear. If you have the Casio, this gray one, it's perfectly good for this set of questions. If you have the TI-84, you can also do this method. The steps are in the back of these notes on page 18. They're pretty clear. I don't think you'll have any trouble doing it. And there are probably hundreds of YouTube videos on how to set up matrices with these calculators. So just type in your matrix name, YouTube it, matrices, and good, fall into the rabbit hole. There's a million videos. Okay, so I've got one more topic, which is solving linear equations. And it looks quite tricky. In fact, you've probably solved linear equations before, and you might remember you need to solve for a variable, you need to put it back in. There's like substitution, there's elimination. You remember all these? Substitution, elimination, and I think there's one other one. It was quite complicated, but if you knew how to do matrices, you could have saved yourself a lot of time. So let me give you sort of the cheats of how to solve matrices. And the long and short of it is this. If you want to solve for x, you want to solve for some matrix x, which I'm going to make clear in a second, it is the inverse of the matrix A times C. Let me show you what this all means with an actual example. I'm going to skip all of this stuff because you don't really need to know it to be able to solve this. So let me show you how this works. This set of equations here, this system of equations actually has three parts. It has the coefficients. I'll write this out. A is what we call the coefficients, which are it's the coefficient matrix, which is the matrix that holds all the numbers in front of the letters. The matrix X is our variable matrix. It's the matrix that holds all of our variables, in this case, X and Y. And our matrix C is our, well, I guess the solutions matrix, or I'll just call it our answers matrix. And I'll color code these so you know what I'm talking about. Our coefficient matrix is going to come from these numbers. Our variable matrix is going to come from these letters. And our answers matrix is going to come from these numbers. Let me show you exactly what I mean. The matrix A will be our coefficients only, in the same way that we see them. You only see a negative in front of that Y up here, so it's actually -1. Our matrix X, this one's a little tricky. It's always a column. I'll make a note of that. The variable matrix is always a column matrix. And we write it like this. just put your variables like this, okay? You'll see why when I finish. The column, sorry, the matrix C is also a column matrix. And you put in your answers. Let me make that centered. All right, I haven't done anything yet. I've just written down what each thing is. So because they didn't give me much space, I'm going to move this up just a little bit. Sorry if you already wrote that there, but I wanted to make some space. Just so you know where everything's coming from. These are all of our coefficients. These are all of our letters that we need to solve for, and this is our answers. And all we need to do now is make our calculator work for us, because we can use a very simple formula. The answer matrix, sorry, the variable matrix, x and y, is what we're looking for, is going to be the inverse of A multiplied by C. So let's do that. Once again, it's not A, it's the inverse of A. That will give us x if we multiply it by C. So just let's do our, show it on the calculator. I'll show it on this one because it'll be more clear that way. It'll take me a second, so you'll need to do this as well. But all we need to do now, we need to put in the matrices A and C. And I'll show you how nice and easy this is. Mode 6. It's a 2 by 2 matrix for matrix A, so 5. I'm going to put in 2, -1, 5, and -3. Okay, save it, AC. Now I need to put in the matrix C. I don't put in the matrix X because they're not numbers. I'm looking for that. I don't know what it is. You need to go shift 4. This is the weird one. You need to set the dimensions of your second matrix. So you go to 1. And then which matrix do you want to use? Because I like to keep the letters the same, I'm actually going to use matrix C in this case, but you could use matrix B. It's the same thing. Let's just use matrix C. So that's number 3. What size is this matrix? Be careful. This is a 2 by 1, 2 rows, 1 column. So that's 6. And it'll show you there visually that that's what you're looking for. I have a 7, enter that, 18. Make sure you press enter here. You should see the little 18 pop up on the right to know it's saved. And now I go AC again. What am I trying to do? I'm trying to take the inverse of A and multiply it by C. So that's exactly what I'm going to do. Shift 4 to get my matrices. Bring up A, get the inverse. Shift 4 to bring up your second matrix, C. That's a 5. And you'll see I have the inverse of matrix A multiplied by matrix C. And if I press enter, it gives me a column matrix with a 3 and a -1. And that's extremely, extremely important. In fact, that is our answer. And the reason that that's our answer is if you look at this carefully, it says our matrix X is this. So let me be more clear. Our matrix X is X and Y, or I should say, if X and Y are equal to 3 and -1, it means that X must be 3 and Y must be -1. And that's our final answer. So I didn't have a lot of space to write that out. I just wanted to write out all the key points. But hopefully that's clear. So the steps: get your coefficients in one matrix, get your C values in another matrix, and just go A inverse C. It'll spit out any number of variables that you want. It could be 3 variables, X, Y, and Z. It could be 100 variables. You can solve huge systems with this with very little effort. In fact, if you had this for your 3 variable systems in any other math course, you would have been a lot happier if you've had to do that in the past. So I'm going to set up another example. I'm going to do a 3 by 3. I'll just do example 2A. And this, unless you want me to do B as well, this will actually be the last example, the last new content or new example that I'll do in this course. And the rest, everything after this point, will be review or just a slight extension to try and get you ready for the final. So let's do this. And you know, it'd be nice if you tried to do this as well, because why not, right? So this is, we have matrices A, X, and C. So we want to solve for X, Y, and Z. So really, I don't need to write that. I want to find X, Y, and Z. And it's really simple. We just solve for the column matrix X. So what it's going to be, let me write it clearly actually. X equals the inverse of A times C. That means our X, Y, and Z are going to be equal to, and let me copy the coefficients, 2, 1, 7, 1, -1, -2, -3, 2, and 3. So you'll notice this is X, this is A. I'm going to say I need the inverse of that. Oops. Times C. And what's our C matrix? It's -5, 12, and 37. Same thing I did earlier. I could color code this if you want. I don't know if it's helpful, but I'm going to do it anyway, just because I'm the boss. These are all of my coefficients that I'm stealing. Don't forget to get the inverse here. The coefficients, sorry, my answers, or the solutions to the matrix in a way. The other side, whatever you want to call it, that's C. And then X, Y, and Z are, of course, you get X, you get Y, you get Z. They're just the leftovers. They go into the column matrix. So put it in your calculator and see what you get. I'm really curious to see if anyone gives me the answers. This will be the last time I give you a chance really to give me the answers in the notes. So maybe you could tell me what it is. I'll give you 2 minutes or 3 to see if anyone writes me and tells you what they got for the answers. So I wrote it there, but I want to see if you can get it as well. Did anyone get it? You're allowed to tell me if you're not working on it because I don't want to wait here forever. But is anyone trying it? Are you having any trouble with actually putting it into the calculator? Because the steps are easy, but there are a lot of students I've had in the past that can't actually get the answer on this. Even if they try to do the steps, they do one thing wrong along the way, and it just keeps giving them an error. So I want to know if anyone out there is having the same sort of difficulty. I mean, we have another half an hour left, so I will be going through some review on this. But how do we feel about this? You've been very quiet today, maybe because it's the end of the semester. Anybody? Are you live? All right. Clearly you have things going on. It's okay. I won't wait forever on this. Let's see. I'm going to actually stop there because these applied problems are something we're going to skip because they're just an extension and we won't actually need to worry too much about them. I'll just double check, see if there's anything. Actually, we can do this last question here. This will be a nice one. To anyone who's still alive out there, this is for you. So it says solve x, y, and z given the following. So it says, first of all, this is a matrix multiplication. And what it's doing here is we're multiplying a 3 by 3 by a 3 by 1, which is giving us a 3 by 1. And that makes sense because we have 3 and 3, which are the same. So our final answer, our resulting matrix, should be a 3 by 1. The trick with this question is if it's saying we need to solve for x, y, and z given some weird situation here. So we actually need to do the matrix multiplication. So it says do the multiplication, then compare the answer, or your answer to that, to the given matrix. And by the given matrix, I mean you're given this matrix, and we're going to compare our answer to that. Okay, so let's do that. Let's do our multiplication. Our answer, I'll just call it A, B, and C. Our matrices A, B multiplied together is going to be x times 1 plus 2 times y plus 2 times z. That's my first row multiplied by my first column, okay? For the second row multiplied by the first column, it's going to be 18 times 1 plus 9 times y plus 9 times z. Plus 10 times z. And then for my last step, it's going to be negative x times 1 plus 3 times y plus 7 times z, or 7z. So let's simplify that a little bit. I have x plus 2y plus 2z. I have 18 plus 9y plus 10z. And I have negative x plus 3y plus 7z. And what that gives me is negative 4, negative 4x, and negative 7. So I'm trying to think now if this is worth completing, because I thought that this question was actually a little bit more straightforward than it actually is. So I'm just going to check what I did for this and see if I want to complete it the way that it is. Yeah, it's okay. It's okay. So if we know that these are equal, then what we actually need to do is make them equal without the matrices, okay? So we know that x plus 2y plus 2z equals -4. So I'm going to set that up as its own thing. I'm going to also say 18 plus 9y plus 10z equals -4x. And I'm going to put -x plus 3y plus 7z equals -7. And I want this in our form that we had before. So we want it in ax equals c form. And what I'm going to do is I'm going to make sure that all of my numbers are on the right side and all of my letters and stuff and coefficients are on the left. So I'll put my first one's okay. I have x's, y's, z's equals -4. The problem in my second one is that I have an 18 here and a -4x there. I'm going to switch spots. I'm going to make sure that x is where it should be, over here, and the number is on the right side. Is a -18. And then in the last step's actually okay. So I don't know if anyone's even out there anymore. Maybe you have other things going on today. But I'm going to keep on going, and anyone who wants to watch the video later can obviously do that. So this is now in our AXC form. So we'll go from this, and we'll set up our matrix in the proper form, okay? We'll say that x is equal to 1, 4, -1, 2, 9, 3, 2, 10, 7. And now I have my coefficients here. I need to get the inverse. And my coefficients are -4, -18, and -7. And this is the exact same thing as saying this is A inverse, and this can be my C as it was before. And set that up in your calculator. What you should get, and I'll skip to the answer because I already showed how to do that. Your answer should be 2, -4, and 1. And what that means is that we have, this is our special matrix here. I should have added one more step just to make it perfectly clear when you look back at it. X is x, y, z, that's what we're looking for, equals this. So x equals 2, y equals -4, sorry for writing on the page numbers, and z equals 1. And that's our final answer there. Okay, so once again, no one's replying, so I don't even know if you're out there. But can I just ask, are there any questions on that, if you're still there? And anything I can clarify? Yes, Ahmed, what's the last step? What about the last step? Okay, so when you say last step, do you mean this part, or do you mean this part, or do you mean this whole last step? The blue, okay, the blue. So you mean from this to this. Yeah, that's calculator. So that's the same thing I did earlier. What you would need to do, and I just skipped it because I showed it numerous times, you would set up the matrix A in your calculator, you set up your matrix C in your calculator, and you go A inverse times C. I can show that again if you want, but that's what I did. I just put it in my calculator, got the inverse, and then multiplied it by a matrix C. You want me to show it one more time? I got a yeah and a no. I actually will, just to make sure, and you can always, turn your brain off if you want to, but this is actually the last chance I get to show you this, really, because again, tomorrow's class is our very last class, and I want to make sure I cover as much as we can before then. So Last time. Matrix mode, set up matrix A. It's a 3 by 3, which is the first option. Put in your matrix A. 1, 2, 2, 4, 9, 10, -1, 3, and 7. And before I go any further, I want to make sure that it's actually the right numbers. 1, 2, 2, 4, 9, 10, -1, 3, 7. Yes, it is. Hit save, which is AC. Go to shift 4. If you're not practicing this, I guarantee you're going to make a mistake when you have to actually do it. I need to dimension a new matrix. I need to make the dimensions of a new matrix C. So hit 1. And then I want to set up a matrix. I'll call it C. And it says what size is the matrix? It's 3 by 1. So that's option 3. And now put in -4, -18, and -7. Now it's saved. I can see all of my numbers here. I need to hit AC again. And then I use shift 4 information to set up the calculation. So shift 4, I want to choose matrix A. Get your inverse. Then go shift 4, set up matrix C. That's the one I saved it in, so that's a 5. Inverse of a matrix A multiplied by matrix C should give me, I hope, 2, -4, and 1, unless I made a mistake earlier. And it does. 2, -4, and 1. So that's X, Y, Z. All right, so hopefully, Tarek, that's more clear. Ahmed, I hope you see that that's how I got that as well. Okie doke. So I want to, since we're doing these matrices, I'll spend maybe another 5 minutes just to show you 1 or 2 more types of what you would see on the final. Because again, students don't often come to the review class at the end of the term, even though I give all of my best information then. So I want to show you this now. I asked you to look at this before, but you can look at this with me now. I'll go through the first part here on Wednesday, but I just want you to look at this type of question. There's 3 different quick questions here, which I'm telling you right now will be extremely important for you to know for the final. Okay, I can't make it even a bigger hint than that. I'm just saying these are extremely important questions. So my question here is, what is the product of this matrix multiplication? What is the answer to this when you multiply them? These don't have numbers, they have variables, but it works the exact same way. So let's get started. Let me show you how. It should be a 2 by 2 matrix answer. I have my rows and my columns. So I have a 2 by 2. So the answer, I know I'm going to have things that are in those 4 spaces, okay? It's a 2 by 2 matrix. The first one is x times -x, so -x squared. And then it's a -y times a -y, so it's plus y squared, okay? For the first row, second column, I need the first row and the second column. Of course, first row, second column gives me this space there. So what do I have? I have xy plus -y times x. So minus xy. It looks like I'm going to be able to simplify that. Let's go one step further. First row times our first column. What do I have? I have a -xy plus xy is what that gives me. These two give a -xy. This times this gives a positive xy, but it's added to it. And finally, second row, second column, y times y is y squared. And then -x times x is -x squared. So the final answer here, -x, oops, these are perfectly fine where they are actually. -x squared plus y squared. These cancel to give 0. These also cancel to give 0. And the other one is fine like it is, but I'm going to rearrange it because it means the same thing. But usually you see x's first. And so this is our final answer, all right? And again, these are 4 different things. So very gently, I'll put in my pencil there to show you it's 4 different answers. They're just placed in the matrix in the corners. Okay? So that would be the first type of question that I really recommend you know how to do for the final. Okay, that's my hint number one. The next questions are very fast. I won't even do this one because I've given the answers on the same sheet. I'll actually just do this next question and then you'll be free, okay? So this is for real, walla teacher. Last question. Let's solve for x and y. We want to solve for x and y. So to be very clear, what are x and y? Of course, it says find the value of x and y, so that should be clear. What it's saying is we need to multiply it out and compare it to this. So we need to multiply by hand and compare to this matrix. I'll just call this A, B, and C. Compare to matrix C. All right, just so that we're clear. I'm just giving it names so that we know what's what. We need to multiply it out and compare it to C. So let's do that. AB is, for the same reason as before, I'll just put the colors in. The first row, first column is 4x plus 0, so just 4x. I'm going to do the first row, first column, that's 12. The second row, first column, it's going to be 2x plus 5y. I need to move this around a little bit. And then I'm going to have my second row, second column is 6 minus y. Okay, that's my multiplication. That means all of that is equal to this. Now, you need to be really smart about how you solve this now. It's actually very simple. You just need to be, like I said, smart or clever and careful in how you choose what you're doing here. I'm going to put this in yellow. Notice that this matrix must be equal to this matrix. So you can compare elements and find the easiest way to solve this. And look at this, 4x is 36. Yeah, so 4x equals 36. So Tarek already has this. It must be 9. So we have x. And if you're clever with your other choice of variables, you can see that 6y, or 6 minus y, equals -1. You could do it a harder way, but this would be the easiest way. And then solve that for y. What you'll see is that it's, what, +7. Because we bring the 6 to the other side, it becomes -1 minus 6, and then divide it both sides by -1. And that, ladies and gentlemen, near and far, is the very last question we'll do today. We will tomorrow, my sound is freaking out. We will tomorrow just go through these examples because I want to review what we did yesterday. But for now, c'est fini, mes amis. So I'm going to stop the recording here. Thank you for watching, those of you that are watching this later.